So good afternoon everyone. We're going to discuss to you hypothesis testing. So what is hypothesis testing? Hypothesis testing was introduced by Ronald Fisher, Jerzy Neyman, Carl Pearson, and Pearson's son, Egon Pearson. Hypothesis testing is a statistical method that is used in making statistical decisions using experimental data. Hypothesis testing is basically an assumption that we make about the population parameter. Key terms and concepts. First, the null hypothesis. Null hypothesis is a statistical hypothesis that assumes that the observation is due to a chance factor. Null hypothesis is denoted by HO M1 is equal to M2, which shows that there is no difference between the two population means. Next, alternative hypothesis. Contrary to the null hypothesis, the alternative hypothesis shows that observations are the result of a real effect. It is denoted by HA M1 is greater than, less than, or is not equal to M2. Level of significance. It refers to the degree of significance in which we accept or reject the null hypothesis. Note that 100% accuracy is not possible for accepting or rejecting a hypothesis. So we therefore select a level of significance that is usually 5%.
Good day to you all. My name is Enzo T. Antonio, and today I'll present you the certain hypothesis testing concepts. Type 1 error. Type 1 error happens when the researchers reject the null hypothesis, when in fact the hypothesis is true. It is denoted by the Greek letter alpha. Type 2 error happens when the researchers accept the null hypothesis, when in fact the null hypothesis is false. One-tailed tests are used when there's a significant claim which states that one is greater or less than the other value. Two-tailed test happens when there is a significant difference, however, it does not specifically claim that one value is greater than the other, or less than the other.
This is an example or a word problem given to us by our professor, Sir Francis Torres. A pharmaceutical company was able to produce a new drug for bacterial infections. They were able to produce a new medicine that is cheaper. A sample of 30 new medicines were taken as sample with an average time of 4 days to take effect. If the average antibiotic takes 5 days to take effect, with standard deviation of 1 day, determine if the new drug has a significant difference between the average drug using A is equal to 0.05. So now, we will head on to the first 4 steps in order for us whether we accept or reject the null hypothesis. First, identify the population, sample, and the sample size of the given word problem. Now, in the given word problem, since it talks about the new antibiotic drug and the average antibiotic drug, we will therefore identify the population as all antibiotic drug. Now for the sample, since it talks about the new antibiotic drug, we will write there new antibiotic drug. For the sample size, since 30 medicines were taken as samples, or rather 30 new medicines were taken as samples, we will write in the sample size 30. Number 2. Determine HO and HA. So since HO or the null hypothesis always states that there is no difference between M1 is equal to M2, therefore we will write there is no significance, or rather there is no significant difference with the average drug and the new drug. For the HA or alternative hypothesis, we will write there is a significant difference with the average drug and the new drug, since there is no claim which of the drugs are better. Number 3. Decide if T or Z test will be used. In this given examples, We will therefore conclude that we will use the z-test since n is equal to 30. Now, for the final step of this first four steps, identify the significance level. This one is easy in the given word problem since it is already stated there that a is equal to 0.05. Therefore, we will write there 0.05.
Determine what tests will be used, and determine whether the problem is a one-tailed test or two-tailed test. Determine also the critical value of alpha. Since our sample size is more than or equal to 30, the z-test will be used. In the hypothesis, it is only asking for the significant difference and not whether if one claim is greater or less than the other. So, we are going to use the two-tailed test. In a two-tailed test, the region of rejection is put at both sides of the distribution. On the other hand, one-tailed tests has the region of rejection on one side, either left or right, left being less than a particular value, right being more than the particular value. Again, since the hypothesis is only asking for the significant difference, so the two-tailed test will be used. Since the significant level is 0.05, 1.96 will be used. You can also refer to this table to determine which alpha is to be used. Step 6. Calculate for the test statistics and compare it with the critical value. This is the formula for the z-test. To solve for the statistics, we will input the values on the corresponding variables. X bar denotes the sample mean, in which the mean of the sample is taken in the research. In this case, our sample mean is 4, which is the average time for the sampled antibiotics to take effect, minus the mu. Our mu denotes the population mean. It refers to the mean of the population that is outside the sample size, or as the whole population. In this case, it is the average time in general for antibiotics to take in effect. In this case, the value here is 5 divided by the sigma. The sigma denotes the standard deviation, which refers to the distance within the distribution. In this case, the standard deviation is 1 day, divided by the square root of n, in which n denotes the sample size, which in this case the sample size is 30. Now, we will compute for the value and we will get negative 5.48. We will graph the distribution graph to plot for the value and to compare it with the critical value. Step 7. We will formulate our conclusion here. Since negative 5.48 is in the region of rejection, then we will reject the null hypothesis. To wrap up this video, thank you for listening.